there, and welcome to... Oh,
Someone forgot that we were switching hosting today, apparently. Today, we're going to be talking about building images using tools provided with Red Hat Enterprise Linux. So that's building virtual machine or cloud-based instance images using tools that Red Hat provides you. Eric, our first tool that we're going to start off with is through our service platform. Why don't you tell us a little bit about it?
yeah, so a little known fact is that out on console.redhat.com, you can get access to Red Hat Insights, which is a cloud-based monitoring and advisory tool that we have. And one of the tools within Red Hat Insights, kind of co-hosted with Insights, is Image Builder. So what that means is you don't have to install Red Hat in order to build Red Hat images. You can just create a customer portal account, go out to console.redhat.com, and of course I'm scrolling through the wrong window here, or wrong part of the window. And as you can see in the Red Hat Enterprise Linux space, we have Image Builder. We talked about Image Builder from a locally hosted web-based approach early on in this series, but today we want to kind of talk through the three different pieces. So the first one is the cloud-based service, and what that does is once you log in, you can actually go through and create an image. As you can see, we've got a drop-down with different versions, so you can get the latest version of RHEL 8, the latest version of RHEL 9, or if you are a partner or a developer of some sort and you want to develop things on Red Hat to get into the Red Hat development cycle, you could even deploy CentOS Stream 8 or 9. But we want to keep things simple here, so we're going to go with the latest version of RHEL 9. Let's say that, see, I've been working with AWS images lately, so let's just, for the sake of ease, let's deploy to AWS. So what this allows us to do is create multiple different images using the same recipe, and but have it configured with different packages, because running an AMI on Amazon is going to require different packages and different services than running a QCOW2 image. So we can actually generate multiple images at once. So I'm changing my mind. I want to go ahead and do QCOW2 just to show that we can build these in parallel. So you notice that when we selected certain options, that our wizard here on the left-hand side changed appropriately. And since I don't know my AWS account ID and I don't want you all to know it, I'm just going to start typing numbers until I get, there we go, until I can click next. So you notice that at least with AWS, it's built in the default region and shared with the account ID that you reference here. And then you can move it to whichever region that you're wanting to deploy your workload in. One of the amazing things about the console version of Image Builder, the cloud service, is that you can actually register your instances and configure them with Red Hat Insights right from the wizard. So we're going to go ahead and register our systems with Red Hat Access as well as Red Hat Insights, and then I can actually send it an activation key, which don't bother writing that down because I'm going to delete these keys right after the episode. So I'm going to go ahead and give it an activation key. That way it gets set up with the right subscriptions, the right repositories, and then I'm going to go move ahead. One of the newest features in the Image Builder cloud service is the ability to manually configure partitions. This has been something that we've been working on for some time. By default, it starts out with just a root partition and it defaults to 10 gigs, but I can actually add in another partition. It defaults to home, so maybe 5 gigs here. And then I don't know how many times as a systems administrator I've been bit by var log filling up, so I'm going to go ahead and save myself some trouble and put a few gigs into var log.
The reason that we added this of creating new file systems is that a lot of places have either a standard file system layout that they want to use for their virtual machines, and this allows them to create that file system layout to deploy on the virtual machines on their on-prem virtualization. or they're cloud-based virtualization, or more importantly, they have requirements for security policies that they're complying with, where the security policy says, thou shalt have a var, thou shalt have a home. And now they're able to actually make images that comply with those security standards.
So now that we've configured a customized file system layout, either based on our own personal or our own corporate image definitions or based on some security compliance, we can also add in a series of packages. So one of my go-tos is, maybe this is going to be an Apache web server. And then one that I'd have on a lot of machines is tmux. So we can go in and add in different packages. And what's really awesome about this is what you don't see is behind the scenes, it's added the 100 or so dependencies to our recipe already. So we may have just added HTTPD and tmux, but we don't have to know all of the dependencies to add them manually. Image Builder is doing that for us behind the scenes. We can give it a human readable name. And then, of course, before we click the big blue button, we have a chance to review that we're going to share this particular blueprint out with AWS. We're going to go ahead and register it using an activation key, as well as register with Red Hat Insights. We can review our system configuration, but let's go ahead and kick that off. Oh, I love it. Live demos, what could go wrong? There we go, hey. And actually one of them did kick off, so we'll have multiples. But so what I wanted to point out here is that notice that we have now 3 jobs because of a 500 error running, but the latest 2 here. So we've got the one building for our Amazon Web Services, and then one building for virtualization. And we can actually check the status of those, and then eventually download the blueprint JSON file, or the blueprints are in TOML file, but we can actually pull down the JSON request, so we could do this via API later on. Scott, any color you want to add to that?
No.
No, someone else forgot that we switched hosting roles.
So if we're finished with our critical path demo, please stay with us.
We could sit here for 5 minutes while they build.
We could. Please stay with us for after the transition. We'll actually be taking a look at the on-premise version of Image Builder as well that ships with Red Hat Enterprise Linux. And we'll be going through a command line-based demonstration, as well as taking a quick look at its web console-based interface as well. That was a bumpy ride, Eric.
That's why we don't ever make any changes to the show format.
So I did see that we did get a question in the chat that I wanted to address. Also, this is the time in the show where people can ask questions and we'll answer them, as well as get into a little bit deeper dive into what's happening in the behind the scenes. So Shantanu, great to see you. I see that you asked if we could build Amazon Linux things. That's an interesting question for the Red Hat people. Just saying. So the goal with Image Builder, and I know that in the follow-up you talked about HashiCorp Packer. One of the big things with why we're doing our own image building service and software is that a lot of the multi-use tools make multi-use tool decisions. And we thought that we could build a more consistent and better Red Hat enterprise image by having a Red Hat tool to make those decisions, because that way we can only worry about the one thing. So yes, tools like Packer are excellent and allow you to build a lot of different operating systems and a lot of different images and output types and other stuff. And what we're showing you is something that comes with the distribution in just a minute, or with the subscription services that you get from Red Hat, and includes things like uploading to your cloud providers storage so that you can import it into your image library and other stuff. The big thing is that when we build it, we're building it the same way for each output format, right? So we know that if we use the image builder tool, if we design our blueprint and click go on the image, and then we're like, oh, wait, I also need that in a VMware VMDK, or I also need that in a QCOW2 image. The actual building of the image is happening in the exact same way, regardless of the output format type, right? How we're choosing the packages, what additional customization we're making, like file system layout, or user accounts that can be created, like all that stuff is happening in the exact same way across the different output formats.
Well said. All right, so definitely raise your questions. Really good discussion there, Shantanu. Glad to see you back after the new year. So we're going to transition over to a command line option, which I'll grab the link because you can actually follow along on lab.redhat.com. So let me grab that and I'll put it in chat. And Scott, you want to walk us through what we're looking at here?
Yeah, absolutely. So first, let me install some software so that we've got it. What we're going to be taking a look at is the on-premise version of Image Builder that comes with Red Hat Enterprise Linux. And we're going to interact with this software using a command line interface utility called composer-cli. So I'm installing the composer-cli RPM and the OS build composer service and software. So that's actually what's going to be compiling the images behind the scene. And you can see that it pulls in like a bunch of dependencies as well to fill that request. All right, once it's finished installing, we're going to enable the OS build service. Well, actually, it's a OS build socket. So we designed OS Build Composer to be a service that runs, or I should say, it is an application that runs as a daemon. And whether you're interacting with it using the composer-cli interface that we're going to see in just a second, or the web console interface, the cockpit interface that we'll see towards the end, both of those interact with the same daemon. So again, we're, regardless of our way of interacting with it, building images in the same way. All right, so at this point, we've got the software installed. The service that's actually going to be doing the image building is running. And we can start taking a look at what's available here. And I'm going to just do an SSH localhost so I can use tab-based completion. It's a unique weirdness about our lab environment. So composer-cli. And if I hit tab a couple times, like these are the subcommands in composer-cli that you can run. So if we want to do something like composer-cli blueprints, well, here are the things that we can do around controlling our blueprints. Remember, a blueprint is the instructions that tell us how to build our image. So if I just want to list the blueprints that are available on this local system, there aren't any. For our example that Eric went through earlier, where he was using the image builder as a service at console.redhat.com, he was asked a series of questions through a graphical workflow that will actually build up one of these blueprint configuration files. But here in the command line world, we have to create a blueprint configuration file. And I happen to have one already here in my home directory called node appserver.toml, which at this point is empty. Okay, so here's what it is. It has a little bit of descriptive properties. And then there's a version that we keep track of so that we can actually see whether our images are built off of different versions of the configuration file. And then we get things like modules, which is application streams, or groups, which is groups of software. All right, and I'm going to add in some additional individual packages to this total file. All right, so I could open up my editor, but thanks to the magic of having done this beforehand, I'm just going to, maybe not. I'm going to try and copy and paste so that I make less typos.
That's the beauty of this particular episode. Unlike our user error episode, Scott and I both ran through all the labs to make sure that it works.
All right. So what see down here at the bottom is that I now have a packages section that says that I'm going to add a package called Nginx. That's going to be my web server. And that's what's going to be built into my base operating system image, in addition to all the normal minimal base operating system stuff. All right, so now that I've got my tonal file created the way I want, I'm going to add it, or I'm going to update the image builder library with it. I'm going to use composer-cli, blueprints, push, and I'm going to push that file into the database of available configurations in the image builder service. All right, and now when I do my list of blueprints, there's my blueprint that I just added. Okay. And if I wanted to make more changes, I would edit that file more and then do another push, which will do things like increment its version and update the database with the new changes. All right. So if I do a composer-cli blueprints show, so you can also use the composer-cli to show you what's currently in the database, right? To make sure that there's not a difference between the file you're working with locally and what we're actually storing in the service. Okay, so pretty simple configuration thus far. You'll notice, however, that when Eric was doing his service-based run-through, there were other things he was doing, like setting the file system layout. Some of those options are also available on the image builder that you can use on-prem, but not all of them, because we at Red Hat decided that we wanted to focus our development efforts to get things in the hands of people as quickly as possible. And so we add things first to the service, because every couple of weeks we have an opportunity to push updates to the service applications. But every 6 months is when we have an opportunity to push things out to the people through RPMs and package updates available with the distribution. So new features always land in the service first, and at some point they get added to the on-prem version, maybe one or more update releases later, right? So it's not always like, oh, I'm going to get the new stuff next release. Sometimes it takes a little while longer for the on-prem version of this application to get updated with the newest features from the service. Additionally, there will be some things where I think it's going to be really hard for us to do that with. For example, what if we wanted to offer an option to do different architectures of virtual machines? So in the service-based image builder, we can do that by just building on a different architecture hypervisor. However, on-prem, we're limited to what hypervisor the service is currently running on, or not hypervisor, what machine, what architecture the machine is that's currently running. So there's going to be some things where it's just technologically not feasible for us to move those features. But generally, they're pretty compatible, if not a little bit behind on the part of on-prem. Wow, that was a really long disclaimer. I'm sorry, Eric.
No, I think it was well said, though. I think to sum up, the quickest to production code features an image builder is a service. The second most is probably the command line interface, and then the third would be the web console local hosted version. And we'll take a look at that towards the end of the episode. But yeah, if you want the latest and greatest features, the easiest place to find that is in the hosted image builder service.
All right, so now that we've got our our configuration uploaded into the service. Now it's time to build our image. So we're going to do a composer-cli compose. We're going to start that compose. And here's the name of the configuration to use, Node App Server. And then the other thing I need to specify is what is the output format, right? So maybe I want a qcal2, or maybe I want to do a VMDK. So you specify the output format that you want to use, right? So again, just like the service and we were talking about earlier, there is the concept that because we're building in the same way, it doesn't matter what the output format is. We're going to build in the same way with the same options in the same configuration. All right, so we can see that our compose has been started. And at any time, we could do a composer-cli status. All right, and we'll see what all is in the queue of composes that are running. And right now, we just have this one that is currently state running. And because we're going to do some more stuff with this image, I'm going to do something a little bit wonky. I'm going to use a new command that we've not covered on the show before called watch. And what watch is going to do is it's going to just re-execute the command I pass it over and over and over again every so often. So the default is every 2 seconds, we're going to run that composer-cli compose status. So every 2 seconds, I'm getting an updated output from this. And what that allows me to do is just kind of watch to see when it completes, right? Because I'll see that it's currently running, and then when it's done, it's going to show me that that compose is finished. And that'll be my key to hit Control-C to get out of the watch and then continue on with my stuff. All right, I see there are a couple questions. So Eric, I saw that you were talking about security compliance stuff.
Yeah. So Rommel had asked if you can embed OpenSCAP profiles into the image, and you can through the command line. So that hasn't made its way into the service. One of the weird exceptions to the disclaimer that Scott gave, where it's in the command line tool before it's in the service. But you can actually specify OpenSCAP blueprint customizations. So your system will come pre-hardened based on which profile you choose. Let's see.
I also see that Rommel asks where the image goes. So I'm going to be very hand-wavy and go, the file system. In reality, what happens is this compose ID, this UUID that we see here, is stored out in the file system with some hideous directory path. And you could hunt it down and find it. I've done that in the past. But instead, what we're going to do after the compose is finished is we're going to use a composer-cli command to just copy it into our current working directory. So when you're working with the on-site image builder and using composer-cli, you want to use composer-cli for all your interactions with the service, because that'll take care of any kind of weird additional data that needs to do or anything like that. So we will, before we access the image, we'll copy it into our current working directory with a composer-cli command.
Yeah, the composer-cli subcommand for that is much easier than the way I went about doing it, where I did a file system search for a .qcal2 file until I found that it's like buried in 6 layers under var. So the composer-cli command is much better.
And I see that Shankar asks, is it seamless to switch between Packer and image builder? I think the answer to that is going to be no, but I've not done it. The big thing is like we have much less functionality in image builder, right? There's a lot less customization opportunities available in image builder than there is in Packer. So workflow is very different between the two. So you're choosing an alternative tool and committing to the workflow that it provides. We've actually, Eric, myself, and some of you may have run into Matthew Yee. We've talked about using Image Builder to build the lab images that we use for lab.redhat.com. And we're like dangerously close to being able to do that with hypervisor support and some other stuff that's happening. But but we're not quite there yet. But if you're working in the large cloud providers like AWS, Azure, Google, the local VMware, or a QCOW2 based image hypervisor, Image Builder is a great tool for building your RHEL images. When I say QCOW2 based hypervisor, like the virtualization software that comes with Red Hat Enterprise Linux, for example, works with QCOW2 image based VMs. Steve Cassidy asks, is there a new kernel or other package in the base instance? So this is actually being built off of the subscriptions of your system. So my system is registered with Red Hat, with Red Hat update services available online. So it's pulling the latest version of the kernel that's available in the Red Hat repos. If instead my system was registered with a satellite server, it would pull whatever packages are available to it from its satellite server. So depending on your architecture, that'll dictate where the packages come from. The other thing that you can do in Image Builder in both on-prem and on services is you can add additional repositories. So if we wanted to, we could add the extra packages for Enterprise Linux repository to Image Builder, either on-prem or service. And then that would open up the ability to install all the software from that repository as well when we're building the images that we're making with it. All right.
We said Image Builder too many times. Mr. Terry Bowling, our product manager for Image Builder, just appeared in the chat.
Oh, we invoked him like Beetlejuice.
Yeah. So I think Steve's the basis of Steve's question was what happens when new packages come out. His example in chat was what happens if we find a vulnerability within Nginx. His question was, do I have to then create a new blueprint? So you wouldn't have to go through the entirety of this process like we've shown you. Instead, all you'd have to do is the composer-cli compose command again to redeploy, whether that's an AMI for Amazon, a QCOW2 file for libvirt. So basically the process that we're watching right now, which looks like just finished.
Yeah, and you can see it as soon as that finished, the watch picked it up within 2 seconds, right? So I'm going to hit Control-C and go back. To just kind of tie off on Steve's question, notice here in the packages where I specify that I want Nginx added to the list of packages, there's a version. So you can actually pin a specific version. I said star, so it's going to pull the latest. So what happens when there is an update to Nginx? There's two things that could happen. One is I probably want to build a new image with the update so that when I fork off new instances, they're getting that updated package just natively when they get spun up. For anything that I already have out there, I can do something like a DNF update, and depending on how it's registered, it'll pull down the updates from whatever source it's registered with. So you can update your existing boxes that are out there in the world using normal system update procedures. And then you probably want to do an increment of your base image so that it gets all of the applicable updates that you want to see in those machines out there in the world. All right. So we are here. We have our finished composer image. And we can do things like composer-cli, compose image, compose status. Right, so this is what I was showing in the watch command, right? But what's important is this UUID number that I have, because that's how we track this specific image on the system. So if I do a composer-cli compose image and paste in that UUID, this delves into the file system. Remember I said that it was out there somewhere, very hand-wavy answer. Well, it delves into that hand-wavy answer and actually slurps out the image. And here it is copied into my current working directory, right? So when you use the composer-cli image command, you give it a UUID and it'll go out and grab it. If you're really lazy and you don't like typing UUIDs because they're really horrible and disgusting, you could also use a little bit of scripting. All right, so we know that CLI compose status gives us that UUID as the very first thing. So why don't we just run that and grab off that that beginning part, right? So this does a little bit of quoted execution, runs that status command, and then grabs out just that first field of the status output, which is that UUID that we wanted, right? Okay, so why am I grabbing this? One is if I was manually going to move it around, now I have a copy of the image here in my little working directory, and I can, there we go, I can move it around wherever it needs to go. But we just did some base image building. Maybe there's some additional things that we need to do to this image. Maybe we need to add some additional content, like some files. So we can do that on our QCOW2 image. And we're going to use the libraries for accessing virtual machine image files to do that. And to make sure that that happens, I'm going to load a module into my kernel. I'm loading this module into the kernel, which allows me to access the file system in a QCOW2 image file. And then I'm going to use a QEMU command to actually connect that disk image to my machine as a device. Right, so I'm using a QEMU command to connect this or create a device, NBD0. And then the actual thing that I'm connecting it, dev NBD0, is this QCOW2 image file. All right, so if I take a look, there is the file system layout that's in my QCOW2 image. And if I mount the root file system, there are the files and directories inside of my virtual machine image. And we can do things like chroot into it. Chroot into it. And if you're not familiar with chroot, what we've done is we've essentially made a subshell, another bash shell, that thinks the /mnt directory is the topmost directory on the system. And the reason we're able to do this is because inside of the mnt directory, there is a bin bash command. So that's what it's invoking inside of this change rooted or kind of this encapsulated shell. So now when I do an ls and I'm looking at the top level directory, I'm actually looking at this inside of my virtual machine. And I can do things like query the RPM database. Right? One of the things I added to my virtual machine was Nginx, and here's the version that's there. If I exit the chroot environment, and now I'm looking at my build system, the build system doesn't have Nginx installed. Nginx exists within the file system of this virtual machine image that I made. All right, we can also, now that we have it mounted, interact with the files there, right? Like, let's take a look at user share Nginx. Sorry, mount user share Nginx. HTML. So these are the files that are inside of my document root for the Nginx service that's installed within this virtual machine. But maybe I want to make my own custom image index.html. So I can do things like this. Right, so I moved it away. And then
Oh, shucks.
I know. Okay. The other thing I want to think about when I'm doing this, though, because everyone's going to jump on me about SE Linux. So we are messing around with the files inside of my machine, and are the contexts within that virtual machine now messed up because they were being edited from outside of the virtual machine. So just to make sure that everything's cool, I'm going to touch the auto relabel file in the root directory of the virtual machine. So the first time it starts up, it'll automatically relabel all of the files that I've put in there. If I've copied them in with the wrong context, or I moved them away and somehow mangled their context, auto relabel will run the first time the instance is booted, and we'll fix that. This will add time onto your boots, right? Because it's going to have to relabel all the things on your virtual machine. So maybe you're not so interested in that. But the reason I have to do it is because I was monkeying around with the contents of the VM while SE Linux is, how do I put this? I'm monkeying around with the contents of the VM on a system where things like mount user share nginx is not a directory that we know what to do with and set the right context for the SE Linux properties of files, right? So the reason that I'm having to touch auto relabel and actually relabeling everything when this instance boots is because I, outside of the VM, messed around with it. If instead I use something like Cloud Init that Eric and Nate talked about a while ago, where the instance boots up and then executes a bunch of tasks as part of its boot through Cloud Init, I wouldn't need to worry about this, right? Because then the VM is running and the VM is making changes that are contextually aware for the VM that's running. Wow, there's a lot of big words. All right. So that's a little bit on messing around with virtual machines built by Image Builder through composer-cli. Eric, you wanted to also show us what it looks like on-premise using the web console.
Yeah. So what I've got here, and I was really excited to do this episode because this is actually how I run my home lab. What we're looking at is the web console for my home lab server. So port 9090. We're looking at the overview page, which, funny enough, I need to go look at insights because I've got some hits. But what I want to point out here is that under apps, over in the left-hand menu, is Image Builder. And so what I've already got here is a RHEL 9. Basically a 9. Latest image. And so what I can do is I can go in and look at what I've customized here. I've given it a host name of RHEL 9X, which basically tells me it's the latest, is going to build the latest version of RHEL 9. I've got my Ansible user here at home, so it actually should have an SSH key. And then in packages, I made sure that bash completion and the enhanced version of Vim are installed on all of my systems. And you notice that it has the 128 dependencies that I didn't have to add by myself. And then notice that I actually haven't rebuilt my my base image to Steve's point since September 23rd. So I should probably rebuild that. But I can do that right here. Excuse me. So I can go in and I can grab the QEMU image, which is a .qcod2 file. I'll keep the default size, and I'll keep the same host name, keep the same users. I said I wasn't going to do this, but it looks like I'm doing it anyway. But there was a question in chat about, do I have to go in and create a new blueprint each time that I want a newer version of software packages or the kernel? So you see, at least using the web console piece, that you don't have to make any changes. It just gives you a chance to review, is this blueprint still current? And to the .toml file example, this would actually increment the Z stream. So you've got major, minor, and patch level in that versioning line. So this is actually going to increment the patch level. So when I save it and then create blueprint, it'll actually kick off another process. So thank you all for joining us, because I just now went in and updated my my home lab's base image. But as you can see, it was, I know we went through it really quickly, but it was basically it looked and feels very, very similar to the cloud-based service. It just doesn't have the same feature set as a cloud-based service. But if you want to just get a very vanilla base image like I've got here, where it's only got a couple of extra packages, you could go through the web console and then use the command line tool if you want to add in additional things like customized file systems, like OpenSCAP profiles. So this gives you a great place to start, kind of gives you the format of the TOML file so you don't have to come up with that from scratch. So using these three tools in combination is a great way to at least get started with this process of building golden images using Image Builder for RHEL.
All right. Thanks, Eric.
Yeah.
So thank you, everyone, for joining us today. I see there is one last question from Rommel Ruby. Is the image size the actual disk usage? So we create the file of the image format, right? So that QCOW2, we said it was 8 gig, it'll show up as an 8 gig QCOW2 image. The actual, like, what is stored within that 8 gig is whatever got installed. So it might only be 4 gigs of use once you boot the machine and look at what's there of its 8 gig of space that was allocated to it through its image file. So yeah, we do, was it fully provision? There's a name for it. It is the opposite of thin provisioning for those. Now, if you wanted to, you could also use some sparsification applications, and you could take that QCOW2 image and you could sparsify it to rip it down to be the size that actually meets what it's using. But I don't believe that's the default for the tool. All right. So thanks, everyone, for joining us today. Don't forget to like and subscribe. Eric loves the likes and the subscribes. And if
Helps
you
me
need
keep our live streaming going.
if you are a deferred viewer, not a live viewer, and you are interested in asking us more questions, put it in the comments. We're pretty good about responding to those. So stay tuned to next week. We'll do another Into the Terminal.
Thanks, folks.